Now we're going to look at unit fractions as parts of a set. So we have four different models here. We have a model that has one, two, three, four, five parts. We have a model that has one, two, three, four parts. Another one that represents three, and another one that represents three parts. Okay, so looking at it using models, you have to make sure that you're reading the question carefully because sometimes you have clues in your question to let you know exactly what you're looking for in your answer choice, and you can actually eliminate some answer choices based on what information is provided in your word problem. Okay, so here's our word problem. It says that Elena and it should say wrote the equation 1/3 plus 1/3 equal to 2/3. She correctly shades a model to show her work. Which model represents Elena's work? Okay, so there are already two answer choices that we can eliminate. Because if we look at our denominators, we see that whatever model she shaded, it has to have a denominator of 3, or the model has to represent 3 equal parts. So we see that our first picture does not represent 3 equal parts. So this model can't be the representation of what Elena wrote the equation for or drew. My second model has 4 equal parts. So again, we know that this cannot be her representation. So now we have two models that both represent 3 equal parts. But remember, your shaded is going to represent your numerator, which your numerator is 2. So if the numerator is 2, that means that the model needs to represent 2 equal parts that are shaded. It needs to represent 2 equal parts that are shaded. If we look at this model here that has 3 equal parts, all of the parts are shaded. So we have 1/3 plus 1/3 plus 1/3, which is equal to 1 whole, 3/3, which is equal to 1. So I'm going to eliminate this as my answer choice. And going back to the other two, the unit fraction will be 1/4 because it has 4 parts, equal parts. And this will be 1, 2, 3, 4, 5, 1/5 because it has 5 equal parts. It's kind of hard to write using the mouse, but just know that I'm trying to talk it out with you as I'm trying to write it, and it all represents 1/5. Okay, so again, we have eliminated two answer choices because neither model represents a third of what Elena drew and wrote an equation for. This model represents thirds, but all of it is shaded. So if this is Elena's model, that means that we need to shade how many parts? Because again, remember, our numerator represents the shaded part. And since our numerator is 2, that means we only need to shade 2 parts to represent 2/3. Each part still represents the unit fraction 1/3. So we have 1/3 here, 1/3, and 1/3. Remember, she wrote an equation to represent two parts out of the three that are shaded. And so her equation does represent this model here. And this will be the correct model. Now we're going to look at another example of how we can decompose fractions into unit fractions, um, especially using a word problem or seeing it in a word problem. Okay, so here's our example. Karen's orange is divided into 8 equal parts. Here is an example of the orange that, remember that an orange, what a whole entire orange looks like. So if you have that visual in your head, once it's divided evenly, it can be divided into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's an orange, and this is the whole. It represents one whole. So this orange was divided into 8 equal parts for Karen. It says that Karen eats 5/8 of her oranges. And I hope I didn't call it an apple earlier. It sounded like I did, but I can't. Oranges. How can we write an equation that shows the fractional part of the oranges Karen has left? Okay, so we are going to first go back to the question and underline what information we know. So we know that Karen had an orange and it was divided into 8 parts and 8 equal parts. We also know that she eats 5/8 of her oranges. And so we're trying to find the equation that represents what she has left, not what she ate. See, I'm glad I went back to reread it. It says the fractional part of what she has left. What does that mean? Well, how many oranges does she have remaining after she's already eaten 5/8 of it? So if you're wondering how on earth am I going to figure out what 5/8 is, I don't understand what 5/8 means. Remember, let's go back. Our orange represents the whole. This same orange was divided into 8 smaller pieces. Okay? So remember, fractional parts are smaller than the whole. So this one whole entire orange was divided into 8 pieces. And remember, 1/8 plus 2/8 plus 3/8 plus 4/8 plus 5/8 plus 6/8 plus 7/8 plus 8/8. All of these pieces equal this whole. If I put it back together, I'm going to get the whole entire orange again. Okay, so if I want to see what she had left, I already know that she ate 5/8. Well, what does that mean again, Miss Glad? I have no clue. What are you trying to tell me? Well, of those 8 pieces that we divided the orange into, she ate 5 of them. So I can take away 5. 1, 2, 3, 4, 5. So now I can see how many pieces Karen has left. So looking at my circle, after I have taken away the 5 that she's eating and the oranges that are remaining, the pieces that are remaining, I only have 3 that are remaining. And since I have 3 that are remaining, the fraction that she has left is 3/8. I can decompose 3/8 into smaller fractions, what we know as unit fractions. 1/8 plus 1/8 plus 1/8 gives me a sum of 3/8. Okay, my denominators are like denominators. So that means that I am not going to change the denominator. I'm not going to change the denominator by adding this and getting 24. No, the denominators does not change because the number of parts of my orange didn't change. So therefore, my denominator shouldn't change. So now I'm going to add my numerators. I have three numerators. All of them have a numerator of 1. 1 plus 1 plus 1 gives me 3. So if I wanted to build my 3-unit fractions, if I wanted to compose my 3-unit fractions, I would get 3/8. 1/8 plus 1/8 plus 1/8 shows how I can decompose it.